With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello student, this is the question ID number 644358756, and in this question a gas of hydrogen like ion is not correctly right, is prepared in such a way that the ions are only in the ground state and the first excited state, and then a monochromatic light of the wavelength 1216 angstrom is absorbed by the ions. The ions are lifted to higher excited state and emit radiation of the 6 wavelength. Some higher and some lower than the incident wavelength. Find the principal quantum number of the excited state and then identify the nuclear charge on the ions. Calculate the value of the maximum and the minimum wavelength. So here you have to first find out the principal quantum number of the excited state and then identify the nuclear charge on the ions, and after that you have to find the maximum and the minimum wavelength. Let's do the solution for this question. Suppose this is n is equal to 1, and this is n is equal to 2 state, and this one is n is equal to 3, and this one is n is equal to 4, and this is the ground state. This is ground state, and this is excited state, first excited state, and this first excited state, and this is second excited state, and this is second excited state, and this is third excited state. Now hydrogen like ion is prepared in such a way that the ions are only in the ground state. So suppose the ions are in the ground state here or here, and then a monochromatic light of the wavelength 1216 is absorbed by the ions, and the ions are lifted to higher excited state. That means these ions are excited to higher energy state. So suppose this is excited state, okay, and the wavelength is lambda here, and this is the 1216. After that the ions are lifted to higher excited state and emit radiation the 6 wavelength. Now this radiate energy radiation from this n is equal to 4 to this is one wavelength, that is lambda 1, and then 4 to 2, and then it can go to this state. This is lambda 2 and lambda 3 from 2 to 1, n is equal to 4 to 1, n is equal to 3 to 1, n is equal to 2 to 1. Suppose this is lambda 3, and then it goes from lambda n is equal to 4 to 2, n is equal to 4 2, that is lambda 4, and it can go to n is equal to 3. So this is lambda 5, and one remaining that it can go 3 to 1, and it is lambda 6. So these are the 6 wavelengths, and some are higher, and you can see that means some are higher than the lambda, original wavelength lambda, and some at the lower wavelength. Now first step, that means step number 1, we have to find out the principal quantum number. Before this, we know the formula 1 upon lambda is equal to z square RH, that is the Rydberg constant, and we can write here R only, 1 upon 2 square minus 1 upon 4 square, and this is for this transition, it is going from this. Then from here we can find out it will be z square, and the R, basically this is RH, Rydberg constant, and this will be 1 by 4 minus 1 by 16, and then you can calculate here z square into R into this will be 4 minus 1, that is 3 by 16, and here you know the wavelength lambda, and then R is also known. So then you can calculate the lambda, this z square from here, z square will be 1 upon lambda into 16 by 3 into 1 by R. Now we know that 1 upon R is equal to 911 angstrom. This is the Rydberg constant, that the reciprocal of the Rydberg constant is 911 angstrom, and now substitute this value, and the lambda is here 1216 angstrom. Now after substituting this value, that means 1 by 1216 into 16 by 3 into 911, then you will get z square is equal to 4, that means z is equal to 2. Okay, so this is the answer of the find the principal quantum number of the excited state and identify the nuclear charge on the ions. So that means the charge on the ions is the 2, that it is a helium ion. That means the ion, this is a hydrogen-like, and the N is equal to 2 for this one. So this is helium 2 plus, and here principal quantum number is 2. So this is the answer of the first option. Now in the next step, step number 2, we have to find out the maximum and the minimum wavelength. We know that E is equal to SC by lambda. From here you can see that this energy is proportional to 1 by lambda. That may higher the energy and lower the wavelength. So from the diagram you can see this is the energy levels, N is equal to 1. So that means if you compare this one lambda 1 and this lambda 5, then you can see that the energy in this transition is large as compared to this one. So that means this is the largest energy. That means the energy, highest amount of energy is required to transition from this state to this state. That means the wavelength corresponding to this transition is minimum. So that means this lambda 1 can be written as the lambda minimum. And similarly lambda 5 or lambda 6, this lambda 5 has the smallest energy. That means this lambda 5 can be assumed as lambda maximum. So lambda 5 can be assumed as lambda maximum. Now our task is to find out these values. Okay, so for lambda max is equal to lambda 1 by lambda max is equal to, because here this is the for helium, Z square RH, and it is the transition. Lambda 5 is 4 to 3. That means it is 1 by 3 square minus 1 by 4 square. It will be Z square is equal to 4. It is 4 into RH into 1 by 9 minus 1 by 16. Then you will get 4 into RH. It is 16 minus 9, that is 7 by 9 into 16, and this is 1 upon lambda max. So from here you can calculate lambda max is equal to 1 by 4 RH into 9 into 16 divided by 7, and it is cancelled here, that is it is 4. It is 36 by lambda max is equal to 36 by 7 into 1 by RH, and we know the value of this 1 by RH, that is 911 angstrom. Then it will be lambda max is equal to 36 by 7 into 911 angstrom. And if you calculate this value, 911 into 36 by 7, then you will get this value is 4685 angstrom. Similarly, we can find out the value of lambda minimum. So it is the maximum value of the wavelength. Similarly, we can find out the lambda minimum. 1 upon lambda minimum is equal to Z square RH, and it is going from 4 to 1. That means it is 1 upon 1 square minus 1 upon 4 square. It is 4 into RH into 1 by 1 minus 1 by 16. So it will be 15 by 16. So 4 into RH and 16 minus 15, that is 15 by 16, and it is 4, that is 15 by 4. RH into 15 by 4, and this is lambda minimum. From here we can calculate lambda minimum is equal to 4 by 15 into 1 by RH, that is 1 by RH is 911 angstrom. Then its value will be lambda minimum is equal to 4 by 15 into 911 angstrom. And then if you calculate this value, then you will get 242. Lambda minimum is equal to 242.93. That means it is about 243 angstrom. So this is the minimum value of the wavelength. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.